Let's prove the following. So we first begin with the scalar triple product between the vector u, its first derivative, and its second derivative. So this can be also expressed as, we take the vector u dotted with the cross product between the vector, the first derivative of u with respect to t, with its second derivative with respect to t. All we have to do is now take the derivative of this particular scalar triple product. So derivative with respect to t of the scalar triple product, that's the same as taking the dot product of vector u dotted with the first derivative of u with respect to t crossed with the second derivative of u with respect to t. Now, using the product rule, we have derivative with respect to t of u. This will be dotted to derivative of u with respect to t crossed with the second derivative of u with respect to t. Plus, we'll take vector u dotted with the derivative with respect to t of the cross product. That means derivative of u with respect to t cross the second derivative of u with respect to t. Right. Now, using the definition of the scalar triple product, so this can be also written as between parentheses. So we have the first derivative of u with respect to t, the first derivative of u with respect to t, and the second derivative of u with respect to t, plus u vector dotted with, now we have to take the derivative with respect to t of the vector cross product. So here also we can apply the product rule. So that will be equals to, so first we'll take the derivative of the first derivative of u with respect to t, we'll take its derivative. So this will give us the second derivative with respect to t and cross it with d squared u over dt squared, plus now we will take du over dt and cross it with, so we'll have to take the derivative with respect to t of the second derivative of u with respect to t. So this will give us the third derivative of u with respect to t. Right. So this scalar triple product goes to 0 because we have du over dt repeating. So that means we are only left with the second term. We will distribute u vector with each of the two terms using the dot product. So here we'll use the definition. So we have u dotted with, so that means this will become u vector. We have the second derivative of u with respect to t, comma, the second derivative of u with respect to t, plus we have u vector dotted with du over dt crossed with this third derivative of u with respect to t. So this is also the scalar triple product between u vector, first derivative of u with respect to t, and the third derivative of u with respect to t. Now here this will go to 0 because we have second derivative of u with respect to t repeating. So we are only now left with the scalar triple product of u, the first derivative of u with respect to t, and the third derivative of u with respect to t. So we started out by taking the derivative with respect to t of the scalar triple product of u, the first derivative of u with respect to t, and the second derivative of u with respect to t, and this gave us the result, the scalar triple product between the vector u, its first derivative, and its third derivative, hence proved.